Check 1, 2. Hey Dominique, cours pas trop vite là. Dominique, tu veux-tu te demander s'il y a du son? Y a-t-il du son dans la présentation? Non? Mets logo. Mets logo.
Good morning, everyone. Thank you for joining us for the final day of Cognitive Science 2019. It's a plenary talk this morning that we've been looking forward to as soon as we started thinking about the theme of creativity in cognitive science. So it's my great pleasure to introduce Dr. Elizabeth Churchill. Her career demonstrates the power of multidisciplinary science. She has combined artificial intelligence with psychology across several areas. For the past 20 years, she's drawn on social, computer, engineering, and data sciences to create innovative end-user applications and services. She's now Director of User Experience at Google and joins us today to discuss cognition, collaboration, and creativity, Google's material design as a case study. Please welcome her to Cognitive Science.
Good morning. I'm really impressed that there are so many people here on a Saturday morning at this time. Thank you. What I'm going to do today is just tell you a little bit about material design, which is Google's design system for devices like this, any kind of screen-based device. And I'm going to take you through some of what the design system is, but also how my background in cognitive science really is shaping the way in which I think about research on the design system. And so hopefully you'll get a little bit of a flavor of that. So when I'm talking about design system, this is the first and only talk probably where people will say you may look at your devices, because I'll be looking at how we come up with things like buttons and bars and any kind of interaction. So these kinds of elements that you see represented sort of schematically here on your devices, on the apps that you use. So that's the context. And the reason I say that is because when I say material design, people often think I'm in hardware, which I am not currently. So what is a design system? Well, design systems became very popular, I guess, about 2011. We've always had design guidelines. We can go back to the early Apple guidelines, the early guidelines for things like the Newton. And we've had software systems from way before that, and systems in architecture, patterns, essentially. But when I'm talking about design languages for devices like this, I'm talking about things like the form, the shape that you see on those beautiful buttons and so forth, the lines, the grid lines, how things are laid out, the texture that you see in any particular element, and you're seeing some of them go through here, and I'm going to show you some more. The space between elements. Space becomes a really interesting thing in particular because it turns out that there are some cultural differences in how people, the density that people want in terms of how much space they have between elements. There are also task differences, so think about a spreadsheet for an expert versus a beautiful consumer application, which is about well-being. You might have different density and space. Motion and movement is another thing. You've seen some movement here, and I'll show you some more in a second. And these movements invite the human mind to sort of think about whether something is smooth. They invite different personality interpretations for a particular kind of interaction. Think about typography and fonts. Part of the material design group at Google includes Google Fonts, where you can see all different kinds of ways of rendering different texts. And again, we're thinking about the personality differences between if you've got a site for a bank, for example, versus somewhere that's a gaming site. Maybe the font needs to be different. These are very, again, psychologically evocative. You're getting people in a particular frame of mind by the design. Content design is also very important. Not just content in terms of what's written on a particular page or site, but also things like button labels, things like onboarding flows. So these are all of these sort of elements of a design system like material design. Some of you may be quite familiar, but I know that some people are not, which is why I like to show some of these. The simple, humble button, here are just some examples of different ways of having buttons, different kinds of sliders. Again, think about the animation. And as you're looking at this, especially in this audience with the expertise you have, think about the underlying perceptual and psychological factors that go into making these both discriminable and perceptible at all, but also what they evoke in terms of people's responses to these as aesthetic artifacts. And we've had a couple of lovely talks, including yesterday's plenary, around artistry and creativity. So here you've got, Here you've got color, grid, layout, again, playing with this idea of placement. So these are some of the, if you want to call them, experiments that the designers make around creating aesthetic and artistic experiences. Here we have some of the fonts I mentioned earlier. So you can see there are different languages, there are different fonts, there's different typography, different spacing. And again, playing with what is perceptible, what is evoked by some of these rendered texts and fonts. These are sort of things that we play with. These are the kinds of elements that go together to making those experiences that you may not have deconstructed before, but hopefully after this talk, you'll look, even if you're not an interface or interaction designer, you'll look a little differently at the apps that you're using. Here we have things like cutouts, which are intended to invite and have you infer as the user a different style of action or interaction. And here you have it sort of coming together, and you see some of the elements of motion I'm talking about. These are some variations on the theme. So material was very much a design system with guidelines around 2014. I'm going to show you some of the early beginnings of material. About 2 years after that, maybe 18 months, it was clear that design guidelines led to a kind of creativity which meant that there were many different styles coming out, but people were asking for engineered components. So here, a collaboration between designers and engineers led to some engineered components. Material became open source a couple of years ago. So I'm going to show you some examples of how the world is using material, which is part of that collaborative creativity that you'll see, which was why I entitled my talk the way I did, which is around collaboration and creativity. But here you can see some different variations using some of those elements that I just showed you that people have tried out. So material design, as I said just now, was launched in 2014. We're now at 2019, and we have what's called Google Scale. Hundreds of thousands of app developers in the world out there using the guidelines from the website, but also downloading our components from Git, extending them, changing them, and I'm going to show you some different kinds of ways of engaging. So there are many different levels of engagement with material design. There are literally millions of websites that use material design components, and there are billions of users. So out there with iOS, Android, and the web, we're seeing a lot of people taking up, if not the entire design system, at least some part of the design system. So about 95% of Google, Android, and iOS apps use at least some aspect of material design. And we have a lot of partnerships in our team with the teams at Google. And we are increasingly moving away from the visual and the aesthetic and into things like guidelines for ML patterns, machine learning patterns, and so forth. For how do you use machine learning patterns? And there are approximately 3.8 million third-party material design apps in the Play Store. Now, I wanted to give you that background so that you know where I am situated in the world, what I do every day. The material design team is about 150 people of designers and engineers and researchers, content strategists, writers, et cetera, et cetera. That's grown a lot since 2014, when it began as a small group of designers, really thinking about how do we make Google's apps more consistent? How do we make them more user-friendly? And that was a direct call from Larry Page at the time. But I might hear you asking, where is the cognitive science in there? And I think what I try to just say is that the visual and motion elements of material really do evoke, and sit upon deep thinking around human visual and interaction capabilities and affordances, proclivities, if you like. So the cognitive science, very specifically in this, you have to go back to me in the 80s. I wanted to show you my haircut in the 80s so that you'd believe me. It was the 80s. And my interest at the time was, I was at Sussex University doing a master's in artificial intelligence, knowledge-based systems specifically. And my supervisor and I were really interested, well, I wanted to work with him, in intelligent tutoring systems. So you can see that in 1988, intelligent tutoring systems. And so I was building systems to try and help students learn the concept of variable. And what I wanted to do was look at how people went through a particular set of exercises. And the language was Pop 11. Anyone in this room remember Pop 11? Thank God. Thank God. There's just 2 of us or something. We'll get a cup of tea later. Oh, 3. Thank God. Anyway, so I was building these tutoring systems so that we could have a student model, identify how much the student knew, and then make some predictions about what they needed to do in order to learn these concepts. Now, I've been watching a few talks here, and I think that's quite similar to some of the things that you've been doing, some of you. Understanding the learner's needs, understanding who the learner is first, some kind of diagnostic process, and then giving an adaptable or adaptive experience to help them get to a point where they learn something that's really critical. So that was in 1988. And then I went to Cambridge, and that was with Ben Deboulay, and worked with Richard Young on programmable user models. And using SAW, the Unified Theory of Cognition. And a programmable user model, for those who don't know, is a psychologically constrained architecture which an interface designer is invited to program to simulate a user performing a range of tasks, a proposed interface. So the idea is you have these different interfaces and you make estimates and you can run this program that simulates the user to figure out how easy or hard or what kinds of errors might come up. And so this was a way of helping designers have these psychological considerations at their fingertips without them having to go and do an undergraduate or a master's in psychology and perception and interaction and all of the things. So it's codified knowledge for the designer to collaborate with experts like yourselves to understand whether an interface was going to be easy or hard to use, and with respect to what. So programmable user models was my background, and that's my PhD. And that drew on, as I say, the unified theory of cognition that Alan Newell and colleagues laid out. So I feel like my roots are very much cognitive science. The thesis was a lot of modeling and then a lot of experimentation. And I think you'll see the way I have set up research for material design is a lot of experimentation and a lot of modeling, and we're building the modeling part, but at scale with millions of users. So if we're there, intelligent tutoring systems, programmable user models. I worked on other stuff, including social media analytics for a long time. 2011-ish, design systems started. Material design launched 2014 at Google's I/O conference. And so I'm thinking that in 2019, I'm still doing programmable user models, but at scale. And so understanding the kinds of things that you know about learning and understanding the kinds of things that you know about perception, and I went to a talk yesterday about cultural differences, is really important for driving some of the decisions that are made for a design system that is essentially codified psychological processing, cognitive science knowledge at scale for designers and developers in the world who don't have the backgrounds that we do. That's the way I think about what I do, or what my team does. So I'm going to go back to 2014 and that psychological, perceptual aspect of material. At that time, this was a group of designers who, you could also think of design as centuries of compiled knowledge of experience, even if it's not always been driven by theory. It's been driven by empiricism, observation over and over and over again of what works with layout. And one of the things is that material for material design is a metaphor. At the time material came out, people were talking very much about flat surfaces for screens. Material, the team that built material, I was not there then, I didn't come until late 2014, material, the idea is to invoke salience through shadow, to show what's more important for the task at hand by saying it's in the front. It is in your fovea. It is very important, and you can see that through shadow. You can see the depth and importance. You can see where to tap because of the placement of shadow. The designers at the time did a lot of experimentation digitally with shadow and the creation of shadow and what would look right. The idea is that dimensionality invites that interaction. So they did a lot of looking at layers and what layers would and would not work. And in this instance, if you want, their informal experimental materials were all created very beautifully, much more beautifully than my HyperCard interfaces that I did for my PhD, where a button was just a sort of a shape, really. And here you can start to see shadow and so forth in the context of different device layouts, experimenting with how this would look, how do the edges look, how do you infer where someone can tap. Anyone in this room spent ages thinking about Fitts law? A couple of people, thank you. The idea of Fitts law is how long it takes to actually hit a target from a particular place. So you see something and you go and you tap that target. And so a lot of these ways of laying things out is about how do you take the eye to the right place and how do you have the movement be smooth and efficient and effective to tap. Anyone in this room spent ages tapping on things and wondering why they're not working? Somebody isn't doing their Fitts law properly, or working with brilliant designers, maybe, I don't know. Oh, my interfaces were terrible always, by the way. So the idea here was also to take that idea of the material and think about how you might invite an interaction with an object itself. If you're gamers, you know people spend a lot of time thinking about which objects are manipulable and which are not. Which ones can sit in the background and remain vaguely sort of pixelated, and which ones you need to render really carefully to bring the eye to invite action and interaction with that particular object by casting shadow and having animation. These are actually physical prototypes that were built when the material design system team was really getting going. And these are in the MoMA. Literally physical cardboard objects around which lighting was put, and then they photographed the different objects from different angles, because they really wanted to do the experiments to figure out what do people see, how does shadow land, how do you then render it back into the digital. So they really were playing around at the time, not necessarily looking at sort of vision and theory, but trying to develop animations that really reflected what people would see in the real world under different lighting conditions. And so you might recognize this. Anyone recognize this physical object? Yeah. Well, you might recognize this. And you can start to see how the physical object and the experiments led to the shadows, and then the branding, and then the appearance of the Gmail logo that has become very famous. And so here's more examples of that elevation that I wanted to show you in less abstractly. So, you know, when you're looking at these apps here, think about how somebody has rendered the different layers in order to invite what is the background, what is the foreground, what is the important thing for you to do in what context. And so you might recognize this. This is the starting to think about the layers of a map. Thinking about human action and interaction and information design through the invitation of the visual and the gestural, so that you can take people through any particular moment of interaction. And this is just in one sort of visual information palette. We now need to think about the motion to the next thing, so somebody clicks on something and where do they go? So very considered scripting across these different task elements from perception to action. So I just wanted to give you that background because, again, I want to say that this may not have been sort of formally thought of as cognitive, visual, perceptual psychology and cognitive science, But a lot of the activities of the designers really followed the path of this empirical exploration and testing. And why I became fascinated with material design was seeing how much thought had been put in early, and then thinking about how we could use methods that I'd learned in my past to actually test some of this at scale, because a lot of these opinions and ideas weren't being fully tested, but they were being informally tested. And as material design got scale, I worked with my boss, Matthias Duarte, and the rest of the team to think about what would a team look like to actually start to, for want of a better word, I don't quite like this word, but just go with me for a second, sort of validate some of the assumptions and extend and push forward and start to think about codifying some of those assumptions with the data, the behavioral data, to start to generate other kinds of opportunities. And I'll show you how we're doing some of that. So there's been a lot of interest in generative design and computational design recently. And so for me, the idea is, how do you take real human perceptual and cognitive understanding and generate designs based in data and knowledge that are more likely to succeed for more people, including people with accessibility needs, for example, with visual impairments, for example. So how do you start to do simulation in that space, programmable user models, and give people those tools so that they don't have to do all of the experiments or get PhDs in cognitive science or whatever themselves. So I'm still in programmable user models. A little bit of a message to the young. You sometimes just never do anything different. You just do it in a different way. So I wanted to take Takashi Okada's comment here that science is to discover the mechanism of phenomena. I thought that was a beautiful description. And I really, really enjoyed the talk yesterday. And so I wanted to preface the science of some of the work that we've done with this, because it is to discover the mechanisms of the phenomena and also to explore the phenomena to be tested. So here is the humble text field. Everybody knows what a text field is. Yay. What we did, one of the first experiments we did at scale, and this work was done by Michael Gilbert, Dave Chu, and Samir Bansal, was to look at what text fields work well and for who. And here you'll start to see some human perceptual and task characteristics that we wanted to look at in our experiments. And I've been listening to some of the talks, and I think you will see things like identifiability, discoverability. Do people know something is a text field? Scannability, readability. Can people comprehend text fields in a composition or form? Findability. Can people locate a specific text field? So it's perception, it's knowledge. With placement of labels, it's language. Legibility. Do people understand the content, the states, the parameters of the text field? Can people see what the bound of a box is? Arguably, this line, which is aesthetically very beautiful, may be difficult for some people. And efficiency. Efficiency and effectiveness. And can people learn even if they don't know to start with? So what the team did was come up with a baseline, which you see at the top, and then the alternatives. And they spent a long time thinking about all of the ways in which these parameters could be changed and relaxed, staying within the best practices that the designers had been trained with. So they were looking to identify which affordance is the primary driver for identifiability, findability, and scannability, and started with an exploration of about 20 variations, and then looked at the most promising directions. I think many of you are going to recognize this kind of approach when you're designing your own experiments. What are the different conditions? What are the different variations we need to test? So here are, if we animate them, here are some of the things, some of the lines that you can see, the text input. And you can see they're quite different, but they have a great deal of similarity. And then a tool was developed so that all of the important elements could be messed with, if you like, selected, to generate conditions. This was an experiment that was done on Mechanical Turk, with thousands and thousands of users, participants. And we did, we put them into various different forms. So there was just the boxes themselves. Then can you find these text fields in these different kinds of fairly standard forms that you've all seen, from the sort of super ugly ones to the ones that have got a bit more design, and had people do a series of tasks. And we also asked them which ones they preferred. So there was basically, can you see it? Do you know what can you click on it? Can you follow through on a set of tasks? Which experiences did you find to be the best? So subjective, aesthetic, and task-based activities. So here was the Fitts law, back again. Where do people click and how long does it take them to click? How messy is the click? And what you're seeing here is, for example, the one on the right. It's a bit more messy. People are clicking in different places. So they're seeing that text field and arguably trying to click on it, not exactly sure where the hotspot is. It sort of doesn't matter because they're getting the hotspot, but you can see the spread a little bit. And in this instance, I mean, we're not saying it's good or bad, just saying that's what we saw. So with lots and lots and lots of tests, there were about 144 alternatives that people experienced. And then there was a discrete set of best contenders that came up. And what was really important here was not saying this is the one. It was saying, by those criteria that we collaboratively specified to be really important for people, here are a set that we think perform best, a set of text field alternatives that perform best when you combine all of the parameters we said were important for the most users. And so the designers then have a set of options of things that they can use in situ, knowing that they're choosing the best options for people with, for example, slight visual impairment, as well as for sort of people in complex tasks and or simple tasks. So the idea here was to come up with a set of options that are principled, based in empirical data, but drawn from visual and task-based understanding of the human psychology of action and interaction. And so if you look at the material.io site, there are recommendations for text fields. And those are based in this work that was done a couple of years ago. So that was the first big experiment we did, and we've done more since. But I wanted to share that one with you because it was this moment where we started to talk about this experimental method at scale, combined with great design, based in really good experimentation principles and also sort of psychological and cognitive principles, really getting out into the recommendations that are part of the sort of public face of material guidelines for design. So what does this have to do with, that was the science, if you like, what does this have to do with creativity? And I want to just give you a few examples around why I think this is creativity. And I'm coming back again to Professor Okada's talk. Creativity is to generate new and useful ideas. So I think there were new and useful ideas generated at the small level there with our team. But as I keep saying, material is an open source system. And so about a year and a bit ago, 2018, one of the things that had been noted was that the guidelines for material didn't allow a huge amount of customization. And people were wanting to bring their creativity around their own brand expression and really use the material system, but push it in different directions. And what we know is that what design systems allow you to do is they allow you to scale quickly, because imagine all of those buttons and so forth. If you were redesigning them every time for a suite of apps and experiences, that's hard to do. You get consistency from a system like material design or any design system. By the way, there are many design systems out there, many, worth investigating. You get this efficiency because you're not redoing work, but you also get teamwork. And I believe that with teamwork, and especially teamwork within a small team, but also teamwork between us, internal to Google, and external to Google, teams external to Google, you really get creativity by starting with an idea and then pushing it. Excuse me. You start with an inspiration and you say, actually, that's not where I want to go. I'm going to put that on the side, but I'm inspired. But you start to create your own. And I'm going to show you some examples. I showed you some of these before. These are different ways of interpreting material and pushing material. And this was called material theming that was launched in 2018, where we gave people ideas, scaffolded different kinds of ways of using material with an idea to say, go in any direction you want, try things out. And we've also done studies. So if you look at the top right, left, that is the floating action button that material recommends. People are super creative out there. Some people have more shadow. Some people increase the size of the icon. Some people make the button much bigger. I would call that pushing the edges and being creative. And some of these work in context, and some of them, in my opinion, don't. But my opinion isn't the be-all, end-all, right? It's about people pushing and trying new things. Here are some examples of floating action buttons that we did not create. We did not create all of the icons out there. So I mentioned all of the apps that are in the App Store. There was some work done by an intern a couple of years ago from Indiana, where a whole load of screenshots were taken from apps in the App Store and then analyzed to look to see where people had taken elements of material and recommendations and pushed in their own directions. Here's some just related to food, which I quite liked, just on food sites. And so here is some of the work where Abadia, Tao, Biplab, and Jeff did some work together to actually try to take that corpus and look at the floating action buttons and see also where things were placed. So here are some of the material design elements, looking to see where are they placed. Can we identify them just by doing a sweep across all of these different apps? And so this is the measuring impact and informing design debates by analyzing this data set. And this was basically 9,000 mobile apps. So here what we were doing was trying to use another set of techniques that may be very familiar to many of you in this audience to start to say, what is going on out there? We have this idea of what material design is. Who's doing interesting things with material design? We also have a yearly competition, and people get material design awards for the most innovative way of doing great design, which might be inspired by material. And again, I want to say that there are lots of design systems out there. I just happen to know a lot about material, and I'm very interested in the ways in which people take it and appropriate it and push it. So the other thing that we do, looking at teamwork, is looking at creativity in teams. So one of the things that we've been doing, and this work was done by Sarah Cambridge, who used to be on my team, going and actually studying designers and developers, looking at the tools they use, looking at their workflows, looking at how they collaborate. For example, when we look at people inside Google, as well as in agencies and in other firms. And the idea here is to say, okay, so an idea comes in. How do you create the designs that you're going to, implement? How does the handoff happen to developers? And what happens in the conversations between design and development around the constraints of each of these domains and disciplines? Another thing I heard in a couple of talks was this idea that constraints are really important, and constraints allow you to push on them. But they also very often allow two disciplines, like engineering and design, to have a discourse with each other about how things need to change or could be changed. So, one conversation might be, I want this animation to look like this. I think that's really hard to implement. Are you sure it's really hard to implement? How about if we did it a little bit like this? Well, okay, well, that might take the real effect away. Let's try doing it like this way. These really rich conversations push all of the disciplines forward. And one of the things we've been doing a lot of is trying to understand how having a design system like material changes the nature of the conversation. Because what you've done is given people tools that allow them to have the discourse about what the outcome should be less about the implementation details and argue about the specific details. So somebody on my team, Elisa Weinstein, did some fantastic research where we thought that having a design system would increase efficiency, increase consistency. But when she interviewed teams, it turns out that people said things like, well, managers said, there's less churn on my teams, and people said that they had more job satisfaction because they could actually focus on the work, not wrangling all of the micro decisions. And so the creativity moved from being about pixel movements and tiny details and sort of pixel sort of positioning to actually being about what is the problem we're trying to solve for the user? What are we trying to do for the end user? And people talked about that as more job satisfaction rather than arguing the details, which I think is really, really interesting. So the creativity was elevated in some senses to the task at hand, less on the details of the tiny specifics. And I think that I'm excited about that. So anyway, so I'm going to wrap up because I wanted to leave plenty of time for questions. We had discussed lots of question time. And I want to come back to that question, where is the cognitive science in this? And I want to give you some food for thought around that. So if these design guidance and this design guidance and code is out there for everybody, I want to look at some of the cognitive science issues that I think are involved and that I've seen talks here where some of the work that you're doing really, really, really could inform and help push some of these areas. Perception is the obvious one. Visual perception and the invitation to the eye, to the mind, to act. Creating salience with regard to a specific set of tasks is a really interesting and important issue. Language. The use of particular terms and words, the amount of time content strategists and writers take to make recommendations and to put things like labels and placement, it's a really, really interesting and important issue. And there was the talk yesterday, which was around how do you get people to collaborate? You don't necessarily say discuss, you say share. These words and how words evoke particular actions and interactions are really, really important. And I would love to hear thoughts from people around, how to address some of that. And when you're sort of global and words mean different things in different places, this is absolutely critical. Information and interaction design, obviously, the tasks, the activities, how you get people to do things, how long it takes people to do things, how confused they are, what kinds of errors they make. These are the kinds of things we track through behavioral logging and data, as well as through qualitative analyses and lab studies and asking people what they think. Aesthetics and artistry. One of the really interesting studies that was done a few years ago by Tao Dong was to understand that in other parts of the world, some of the things that we think of as fantastic aesthetics from the material aesthetic point of view are not necessarily shared. Also, aesthetics around density, very important, not just for cultural assumptions, understandings, and preferences, but density for different kinds of expertise level I mentioned earlier. How much information do you want on a screen? And then throw into that the idea that you want something that is adaptive and reactive and responsive, because very, very low-end devices with very poor brightness capabilities, you can't have the same kind of density that you can if you have a high-end device. How does that adaptive sort of layout and information representation work? Because you're really inviting a different kind of cognitive engagement with the information. And if you design for one high-end kind of device and someone's on a low-end device, but the information is presented in the same way, you've really created a real cognitive barrier. I've mentioned cultural dynamics a little bit. Experimentation. I hope I've showed you that some of the things that we do really are drawing on some of the methodologies that I learned way back when to try and really get at not necessarily what is the right answer, but what is the answer for a particular element or a particular task flow in a particular context, and for what population. The work that we did on text fields ended up leading to a really, really deep collaboration with the accessibility team at Google, because they were, oh, finally, we've actually got the data to show which are the parameters and what are the kinds of settings and situations where we really need to have a stronger recommendation around certain kinds of accessibility. And Michael Gilbert, who I mentioned earlier, from my team, who was one of the leads on that work, is now actually advising on the accessibility standards and guidelines committee. So we're taking that up, and we're back to that idea that you do something in the small, but you use these platforms to scale to the large to make recommendations. Co-creativity. The idea that the design system is a be-all and end-all is absolutely not the case. It's a provocation, it's an invitation to be creative, to push the boundaries. And we're getting to the point where we're also doing some of this behavioral and predictive analytics. And so I want to talk a little bit about that, but I want to also go back to some of the talks here more explicitly. So in the first plenary, Mary Lou Maher commented on computation and creativity. And so some of the things I've been talking to you about are sort of in the form of recommendations and experiments that lead to guidelines and so forth. And here she talks about building tools to support users' creativity. Well, Gallery, which is part of the stable of material, is a tool that is explicitly intended to close that gap between design and development. Remember, I talked about some of the field work, which talks about how if you give people a design system, you have designers and developers having a different kind of discourse with each other around the creativity at the level of task or engagement or user. Gallery is a tool which is supposed to close that gap and is being taken up within Google and externally. And with Gallery, the idea is that designers can share designs in one space with developers, because what we found was that there's a big gap. So the designs are and recommendations are all over the place. Then you have to go and pull those, and then you have to work on them as an engineer. The idea here is to have a single workspace where that workflow can be a collaborative space rather than a handoff space. So I wanted to really say, Mary Lou, yes, more tools to kind of reduce the cognitive load and the collaboration load and increase the creativity on task. Excuse me. This is also segmentation that the team has just done about different users of material. And across many studies, this is Abla Hamilton and Jude Yu did a synthesis to look at different styles of engaging with the design system. And, excuse me, the two that I'm particularly interested in connecting to this audience with is this learner category. We see many people who are coming in as learners of design, and the makers and adapters. We also have a lot of people who are design influencers and decision influencers, who are executives in teams who are coming to try and understand how to implement their own design systems based on ours, or to just, adopt ours in their companies. And brand owners. So one of the things we did that I showed you with the sort of ability to be creative and push material is we gave people the opportunity to really have their own brand. So we see decision influencers and brand owners as very interested and using material, but I'm particularly interested in the learners. So one of the ways we're looking at how people learn is how they traverse through the material.io site. What is the way they go through the site? What are the paths and the navigations that they follow? What are the questions they ask and the feedback they send? In the Git repositories, what gets downloaded and what issues are logged? These are all learner questions to be analyzed and that we're looking at in order to try and think about giving people different navigation paths through the material and different feedback. That feels very much like my passion when I was doing my master's on intelligent tutoring systems. How do you take people through material so that they learn and they onboard in different ways? And we understand what they don't understand. Same with the makers and adapters. So a tool like Gallery allows people to come together in one place. And we've been looking at taking logs and understanding where micro assists and recommendations could be really, really helpful. I remember when I was doing some design work years and years and years ago, when I discovered, does everybody know Snap to Grid? Snap to Grid. It changed my life. So what's the new Snap to Grid, What about autocomplete in email when you start to type someone's name in? These little things which are based on data and are predictive are so critical. It's the little things. And that's where I think it comes back to the cognition and task elements that you're all looking at. Where are those little moments that we could actually use data to actually make it so much easier cognitively for people to learn or to continue tasks? This is Jude in the background there. Jude's been driving this data and analytics program that we just kicked off last year, and we're really building out now. And I'm hiring data scientists in Munich, if anyone's interested. And this is the flow we're thinking of. What does it look like? Awareness to understanding, to adoption, to implementation, to adaptation and appropriation. This is deepening engagement. Do you know about material or design systems in general? Do you understand what they are, how to use them? Have you tried using them? Are you building your own components based on ours or extending ours? Are you adapting the system, like the theming stuff I talked about? And are you appropriating the idea of having a system like this and building your own? Each of these different depths of engagement require different signals in the behavioral logging to understand where you're at so that we can adapt services and presentations and information for you. And what you see there is a data mapping workshop that Jude ran, where we were putting up every kind of data stream that we might want to look at, from sentiment detection on Twitter to downloads in Git from the Git repos to, asking people questions, to doing that kind of analysis of the screenshots that we've done before. So we were looking at all the different data streams to understand how to triangulate the data to deeply understand engagement and need. And of course, we have a lot of events as well, so we just talk to people a lot, which is quite nice. So I wanted to come back to the last couple of thoughts. So I was at the panel on how does the current AI stack up against human intelligence. And John Led made this wonderful point that the dominant AI methodologies, no matter what you're doing, if you're starting from some kind of, a priori knowledge, or you're trying to use an existing algorithm, or you're starting from scratch, there's always humans in the loop. Always humans in the loop. And this idea that, the humans are just not part of the process. It's whether you're building the algorithm, choosing the data, cleaning the data, organizing the data, there's always humans in the loop. And I think this idea of human augmentation through algorithmic assists and a partnership, a collaboration between some of the techniques and between data that's been effectively gathered and sorted and organized and analyzed and assists and micro-assists, and that idea that we are all part of the big collaboration and cooperation and creative moment is kind of where I come from. And it's sort of unsurprising, I suppose, because I come from that same SOAR background that John Led does. But I really like this kind of way of thinking about the design system that I'm involved in, which is that you do some basic science, you draw on basic science, you build some things that you think are going to work, you design some stuff, you test the stuff in the abstract, you put it out in the wild at scale, you do experiments and understanding, you do qualitative research, and you move the whole system forward. And that what the system is this codified deep knowledge of human action and interaction and perception that changes through time, and that you're building basically this giant collaborative network of great engineers and designers who care about great design for people, and that we're in it together, helping each other move things forward. And I've just been talking right now about the visual and interactive on the screen, but we're also doing a lot with regard to non-screen devices and other kinds of design patterns. And, that world is, a giant, interesting, exciting world too. And so I think there's a lot of work to be done. And so here we are. There's my journey that I shared with you. And I'm very honored to be here because I feel like I've kind of come back to my roots in cognitive science. And it's been really exciting to see the talks and see some of the fantastic science that's happening. And to think about how would I take that home and put it into scale with this giant team of people who are trying to build great interfaces and interactions for people all around the world. So I think I'm just doing programmable user models at scale again. So as I say, a caution to everyone. I think we just do the same thing, just in different contexts. So I want to thank you very much for your attention. I want to thank you for your talks this week. Very inspirational. And I want to thank Michael, Jude, Dave, Samir, Zaina, and I also mentioned Abla and a couple of other people, Sarah, who I didn't get to put on the slide, but apologies to them. But thanks to everybody, and thank you for your attention.